second video.
Yes.
This may be, again, we are trying to do the right.
Okay, right. Second process.
So now, basis this, we run one algorithm, and to compare like how the performance of the second user is with respect to the first user. Okay. So this is the kind of I mean, this is just I can run it, but just to tell you, this is kind of a comparison wherein it is showing like in terms of data points how accurately the second video
Okay.
video, right? So it is giving you some numbers like
Values
in terms of percentage kind of accuracy.
Okay.
So if you see, like, most of it he was correct, but there were minor issues only, but most of it was correct, right? Now I can come to like how we are doing it, right? And then we can discuss on other things, right? So
this is based on the comparison with the first, right? First as a
exactly.
reference. Okay.
Exactly. So what we do here is we when from the video. So video is, what is video? Video is a combination of frames, right?
Yes.
So from each frame, we extract these data points, 32 data points, if you see in this figure, right? And so we track these coordinates, right? And basis these coordinates, so we can basically track the coordinates of the human, or we can track the coordinates of the fingers if it is required. The these are the different data points. These data points, we put this input in a basically what we do is we put the stream into a tracker engine as an input, and this engine gives us an output as the coordinates. This kind of coordinates is as you see, right? So this is coming from video 1, and another is coming from video 2, and then we feed these stream of coordinates into the analytics engine, which takes some other inputs like the configuration parameters I will discuss, and basis analytics result, which we just saw, right? Which we can see on either on desktop or a mobile app or somewhere.
Okay.
Right.
Okay.
So this is the basic concept, like how we are approaching it.
Right. Okay. Okay. Wonderful. Yes.
So now, if you see like some more inputs, so like for example, this is airports 1.mp4, and it is generating a stream of coordinates for all those. So in this example, we have taken so it has 20 data points, and it is generating a stream of these 20 data points, frame to frame.
Frame to frame.
Similarly, from the second video. From the second video, we got this stream of coordinates, right? And so this is like, you can say one is the best way of doing it, and the second one is the person who is actually trying to follow.
Yes. Okay.
So what we do here is, so this is like what we do is we calculate we define the lines between the different data points, okay, and then we calculate the angles between the different lines, and then we compare those different data points actually to determine like, okay, how much deviation is in the video 2 from video 1.
From video 1. Okay.
And then there are some complex algorithms, like how do we determine which frame to compare to which frame, when to start comparison, when to
yes. Okay.
So those kind of advanced algorithms are there. And what we can do, we can do many things actually. We can determine percentage deviation of video 2 from video 1, average deviation, maximum deviation, minimum deviation, and we can define more parameters, whatever we want.
More parameters, yes. Okay.
Yeah. So this is the kind of summary. Rest of the things is kind of more details on approach, and so this is what we can do.
Okay.
Right. So just wanted to tell you. Now we have a mechanism for determining how much accurately the worker is working on the assembly line. If he's doing good, if he's doing bad, how much good, how much bad. So that kind of thing we can do.
We can identify. Okay, now I have certain.
Acha, Alok, if you remember, we were talking to Satish and all.
Yes.
So he had the specific requirements that.
Yeah. Yeah. Go ahead.
Is also skipped one. Second is जो depth of the gauge है वो हम कैसे देख सकते हैं कि मतलब वो कैसे हम AI के अंदर लेकर आ सकते हैं.
What is that? Can you repeat?
जो गेज का जो नापने का डेप्थ होता है ना, जैसे चैम्फर होता है, तो एक तो उसको कैसे हम मेजर कर सकते हैं. अगर वो हमें वो मेजरमेंट स्केल अगर मिल सकता है फ्रॉम AI पॉइंट ऑफ व्यू, प्लस the operator is not able to say, he's not skipping any of the inspection standards. So ये भी because ये भी एक requirement I.
So we have to define the analytics that we require, basically. Number one, okay, what are the things that we need to measure as a deviation? So we have to first identify that, which we'll speak right now, that what exactly is the requirement. We understood the whole process now, what we are trying to do, correct? And there are a few points which Naveen also raising. I just want to also ask. Number one, last time you were discussing that you need a lot of data point to model it. Now, with the one video you have can compare with the second, instructor versus follower. So is it possible that with lesser data we can do it? Okay. So this is the first thing.
Yeah, we can do it with lesser
constraint. That was the con, because we need one reference and from where we can track it.
Exactly.
Okay. Secondly, I want to know that with the finger points, so without sensor, so how many it is with multiple sensor, with the just one hand, how we are able to manage all those points, getting.
So this is from the video only. So we just need the video inputs. That's it.
Not through sensor.
Not through sensor.
So video frames, frame by frame.
Yeah, you can give me any video of two people. I'm like I showed you two videos, right? And we can do this.
So in video, you are defining those points, right? Within the frame.
Yeah, exactly. So we are defining like these. So we are defining those human body points, like as I mentioned, like the 20 data points in the hand and 32 data points in the body.
Okay. But I just want to know, like, video cannot be simple because people hand will move in some other direction. So are we defining those fixed points, or through image recognition we are identifying those points? How we are doing it? Because I just want
we are doing it through video analytics. So this is this tracker engine, which I am showing you.
Tracker engine, yes.
So this is video analytics engine. Okay. So what it does is it captures each frame. From each frame, it generates these data points. Okay, like at this point, his finger was, this 0 was at this coordinate.
Yes.
Point number 1 was at this coordinate. 2 was at this coordinate. 3 was coordinate, and so on. So for each frame, we are able to identify those data points, and basis that we are able to.
So I'm saying that when hand is moving, those data points are fixed, right? Because hand recognition is there, right? This is
hand recognition is there, body recognition is there, even the joints recognition is there, right?
Okay, joints recognition is there.
Yeah.
Okay. So this is okay, one part. Now, second thing that wanted to know, what should be the clarity of the video to, do all these things? It is, SD quality. Is the video has some level?
Yeah, good question.
Or the lux level or something?
Yeah, so basically, lux level I think will not matter much. Just that normal 720p should work for us.
So video quality, normal video quality will work, right?
Yeah, 720p should be good enough for us.
That's a 720 pixel. Okay. Another thing, can you show me that graph? This graph basically.
Yeah. So this is like one.
So can you what is that one data point represents? Like suppose one data point has gone down even to 10% level, or sorry, 5% level.
So basically, what we are doing is, let me show you something more on this if you want to see. So this is kind of a high level algorithm. Just focus on the central part of it. Don't focus on the left and the right part. So what we are doing is we are finding the frame. Let me explain it here. So what we are doing is we are trying to find where to start comparison. So for example, let's say we have 300 frames here, and we have, let's say, 300 frames here, or maybe even more, right? So what we are doing is, first is we are trying to find out which frame
To
is
compare.
closest to the next n frames.
Exactly.
Right? So we are baselining the videos basically.
Exactly.
So once we baseline the video frames, then we start comparing the each data point, like 0 with 0. For example, let's say this frame is best matching to frame 3. So we will compare one with this one and so on. And then we will compare this second frame with the fourth frame, third frame with the fifth frame, and so on.
Yes, yes.
And we have defined, like we have some algorithm. How do we do that comparison? How do we so it kind of, you can say, we measure the different angles between the different lines that are there, and basis that we are able to determine how much accurately he's doing.
Okay. So can you come back to the graph? We understood that first you have to create a baseline that for the comparison, like which frame has to be compared with what frame. And when the comparison is made, so it is the percentage deviation, right? And if the deviation is less, the percentage is higher, right? Or it's a deviation percentage, what you were saying?
So this is like the best match. So if the coordinates are same, both the coordinates,
coordinate is 100% means there is a zero deviation, correct?
Zero deviation, exactly.
Okay. So I'm saying this particular point which has gone down, it shows that basically that most of the, basically it is not following the sequence or the operation, right? Because only 5% following and
he was doing something else.
5% is, say, deviation, correct?
Yeah, exactly. So if you see in this, if you see, like there are 5 frames here, 1, 2, 3, 4, 4 frames in between these 2 points, and where he was not doing good. Okay. If you see here, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So he was not doing best here, right? He can improve here. This is just a very small example.
This is one cycle, or this is a multiple cycle mapped?
So the video which I showed to you, it had 250 frames in roughly. So this is comparison of 250 frames. 250
frames. It means one cycle is broken down to 250 frames, right?
Yeah. So the small video which I showed to you,
yeah.
Right?
So it's a one cycle only. Doing one cycle, correct?
Yeah, that had 250 frames.
Okay. Now I wanted to know how we'll come to know this particular data point identification, that which out of, say, 250 frames, this is the number. So which activity is basically is not performed? How to trace back that? Can we trace back that? Suppose
we can identify the frame number, right? I tell you. We can identify the frame number, and from frame number we can determine, like, okay, what is the time that so for example, each video has some FPS, frame per second, right? Yes. So from FPS, if you know FPS and if you know the frame number, you can determine, okay, where what is that
exactly is not performed well. Okay. Now, is it possible to label the frames for say 1 to 10? This is like if I say 1 to 10, he's just picking the, say, the iPod and then opening the cap, right? So can we label the frames, say out of 200 frames, can we label, say, 1 to 10 frames is this labeling, 10 to 50 frame is this job, and so I know which frame is not
be possible.
So okay, so that is possible. Okay.
Yeah.
Okay, so then it is and in analytics we can show that which activity is not performed well, and we can calculate for different frame, different percentage deviation. So out of 200 frames, so we say first to 10 frame, 10 to 50, and 50 to 150, and 150 to 200, say example, which will not be uniformly divided, but every frame, what is the performance? So we'll come to know.
So what you can do is you can define some parameters, like how what should be the graph should look like, like what should be the criteria to determine the it's mathematics basically. So you can define some mathematics, what you want to define. You want to, for example, let's say if it is on average, if it is more than 80%, you say it is good, very good. Or if it is between 80 and 60, he needs training, right? Maybe something like that. You define some criteria, and accordingly some labeling can be done.
And if you have multiple cycles, so do we have any, again, another mathematics to have average out all the frames? And
we can do that.
We can also do that, right?
Yeah, we can do all sorts.
Say 100, 200 frames data, and then we will show it as a one frame, as you have shown right now, and that will be average values of all those
So it's like see, everything else is just mathematics and
analytics.
software.
Yeah, analytics I'm talking
So we
about.
can do anything on the analytics side, mathematics side,
Okay.
visualization side. So
Now,
the challenge that we had earlier was, to get these data points. Now we have those data points, we can do anything with that.
Just wanted to know some more detailing on that. Suppose because the guy will be doing say whole day, right? So the video will be captured, okay? And can we see real time or what will be the lag? Because we want to know because data is captured through
So
video.
as of now, yeah.
Yes.
Yeah. So as of now, it is being done offline, right?
Yes.
So real time challenge is that we can also do real time, but challenge is that the analysis will not be real time. There will always be some lag. So I will suggest that you can have it in two phases. One is offline, right?
Yes.
And the second phase might be the real time, near real time.
And offline means
Like it has to process so many frames.
So there will be basically the setup would be something like there will be a video capturing mechanism over there.
Yeah.
Right. That video will be sent to certain, maybe server or something.
Yes.
Because I want offline also to be online kind of thing,
Yeah, that will be online.
Yeah.
Just that will not be
like on a cloud server, right? Capturing and then analytics coming.
If you
Maybe
see,
the difference is 4 hours or 2 hours. I don't know.
My screen is still shared.
Yeah, it is shared. Yeah.
Okay, so if you see this diagram, everything is in the cloud except like from wherever the stream is coming. It might be your IP camera, it might be mobile, or it might be some other source, right? So from wherever it comes, everything else is in the cloud, running on servers and generating the analytics, which can be seen maybe on the web or on mobile. So depending on the requirement, what we want to do with this data.
So if I say,
so the key thing here is the central part, right?
Central part. So what will be the lag if I say, if you do it offline also, the data is sent, then the whole process will have a lead time to do it and analytics will come. So maybe what is the lead time of processing the whole data which enters over here as a complete throughput?
So do you want to define the data? For example, in this example, I took a data of, I think it was 250 frames. So if it is, let's say 16 FPS, right? So it is, let's say, and it takes roughly 30-40 seconds to 1 minute to process it. 30 seconds, you can say, approximately. Okay. Right. So depending on the length of the video, it may take some time for comparison.
Okay.
But it will be not very huge. It will be in minutes only.
Okay. Can we have continuous data like?
Yeah, we can have. We can have it.
And then keep on doing the analytics and then remove basically those frames. Basically, because whatever is analyzed.
Yeah, everything is possible. Just that we need to.
Okay.
Yeah. All those things are possible. Just that we need to be very concrete on the requirements, what we want, and accordingly, all the things are possible.
Okay.
So the only challenge earlier we had is we did not have those data points. Now we have a mechanism to find those data points.
Yes, to gather those data points. Earlier we were thinking from sensor or those things, but through the video we can do it. And what is the accuracy of this video to convert into those frame and deviation? What will be the accuracy of the system?
Yeah, they're pretty. So these data points are pretty accurate, right? And the next thing is about the accuracy of this analytics engine. So for example, like we can define our approach.
Tracker engine basically, which converts into
this is pretty accurate.
This is pretty accurate. And once the video coordinates are sent, that is analytics, right?
Yeah.
That is, I think, not a problem at all.
Yeah. So this is something, this is the algorithm which we have defined.
Okay.
Is argue on that. Okay, this is better or that is better, right?
Okay. Right. And if I say, if people work for, say, I have a station of, say, 10 stations, and I decide to take care of 2-3 stations, which are bottleneck or critical, say example. then there are 2 shifts, so I may get 16 hours, say. Sometime there will be lunchtime tea break, so that is, we can say, okay, we can minus that. So we'll get a 16 hours minus something. So maybe say 14 hours, 14.5 hours or something data which is coming to the system, which needs to be analyzed and find out basically if basically wherever the deviations are coming very higher than the reference values, then we have to track those deviation and inform, like an alert to go, because those part has already been produced, right? So we have to track those parts and maybe stop those parts. So we have to also think the accuracy of, when it is made, and traceability would be the major part in this whole process. Because if we know the error that somebody has committed, so it must have made certain production part or inspected some parts. So we have to find out that ultimately which part is the suspect basically. So we should also have some analytics to say that the parts produced at this time, or if we can have a, cycles also mapped, right? There's a once, if I say this earphone, you're putting it iPod into these slots, right? This is one cycle, 200 frame is one cycle, and you have done say for 100 cycles, correct? So then I can tell, say 50th cycle is a problem. So I know the 50th product is a problem. Then it is the job of the, manufacturing process to identify which is the first 50th part. So time and the part, if we can identify, basically for you part is cycle basically.
I hear you. I hear you.
So the cycle basically. So we have to also map a number of cycle which have basically similar trends. Correct?
Yeah, got it. So,
yeah.
Right. Yeah. So I think that is also can be easily done. Not a problem. So the reason is that the thing that we are doing one time, we have just to do it continuously.
Continuous time, and you have to also have some algo written in some form that suppose I've identified what is called picking, right? And if those trends are not coming, then we have to ignore, because it means no part is happening right now. So I'm cleaning machine, so this is not happening. So, or there's a stoppage over there, so my cycle will not run. So I have to identify only those frame which actually the complete cycle. Okay, so you will come to know when production is on, when production is not on. So I don't need any time to feed in. I don't have to tell what is the start time or when the production is not happening. So it would be, if this system has that intelligence to identify a particular cycle, this is cycle. So, or we can identify what is called this cycle, one cycle.
So think of it. There will be some manual inputs, right?
Yes.
For example,
yes.
One is the reference video, right? Stream 1, which yes. You can say cycle 1, right? This is fixed.
This is fixed. Correct,
right?
Correct.
So based on this reference only, this analytics will work. So it will consider, okay, let's say these are 250 frames. This is counted as cycle 1.
Correct.
And immediately after that, 251st frame is the second cycle. Yes. So that is something like some sort of manual configuration, one-time configuration that you need to do for analytics engine, basis which it will consider, okay, this is my cycle start, and I need to compare it back from stream 1 after 250 frames.
Okay. So I think just wanted to know from you, when you are tracking all those points, you're tracking the position coordinates, so quality of the activity, if I say, right? Are we also tracking time in that?
So time can be determined using the number of frame, as I said. Like if you know the FPS, frame per second, and if you know the count of frames, you can always determine
what is the total time we have consumed for one cycle. Okay.
Yeah.
Because just wanted to know, because somebody is doing fast, right? There can be chance of error, or doing very slow. So I think there are two parts. One is the coordinates of that, where the coordinates varies. It means you are not performing as per the instructor. Or second is, if you are very slow or very fast, that can also bring some kind of errors.
So see, if you're slow, yes, you will always deviate high deviation from stream 1.
So it will show the deviation if it is slow from the frame.
Yeah, definitely.
So it will include that also, right? Time.
Yeah. So think of it like it is driven from this comparison logic only. Okay. If he is slow, he will start this deviation, will keep on increasing.
Correct. This is what I want to know. The time should consider into account, because
So
in the deviation.
think of it. It is a simple algorithm in the sense that we are finding out finding out the reference frame.
Yes.
Once we are able to find out that reference frame, after that it is one-on-one comparison, right?
Yes.
So if he missed some step,
yes.
so there will be deviations shown. If you think of it, like if he's dropping for 1 second, right? 1 second means if you're giving me 16 FPS, so it will be 16 frames dropping out.
Yes.
Right. So it will be depending on you can also give me 50 FPS. It depends on like the camera you are using, what are the settings you're using to capture the video. So, but if you have the better camera, it will show you it will give you more frames to compare. But more frames to compare means analytics engine will have more work to do.
Okay. Yes. Okay. More work to do. Now, if the process is very fast, because some machines and speeds are very fast, right? Just wanted to know, can we still break down into frames? So
yes. Doesn't matter for me.
Because our all cycle times of doing anything is within 20 seconds.
So think of it like what we simply need is two videos and some information about the videos. For example, whether both the videos are kind of have the same quality or not. So we can find out those qualities maybe automatically as well. We have not done it before, but we can definitely try to find that information as well.
Yes.
And all those things can be automated. But the assumption here is in the current demo that both the videos are taken from the same.
You
can say both the videos have the same quality attributes, same number of FPS.
Same. Yes, understood that.
Yeah. But yeah, if it is not the case, we can also even try to find out, to baseline those FPS.
Yes.
So that is also possible to do.
That is also possible. Now, another thing that how much the breaking down of frame per second also impact the analysis. My point is that suppose I have a work which is 1 minute job to complete one cycle. I have a job which is 10-second job, right? Now 1 minute job, even if I don't need say 100 frame per second example, because then no activity is actually performed over there. So I can reduce the frame requirement, right? FPS requirement. For certain job, I have more critical requirement to look into the frames because the entire cycle is done in 10 seconds. So I have to, dive in more and break down into more, frames. So what I want to say, the deviation will also depend on what is the FPS I'm analyzing basically. It's like a discriminating power.
Actually,
right?
Think of it. Think of it like if for me here I'm not caring about FPS, right? If you see, it is only frame for me. It is only like number of frames.
Number of frames.
So if you see, if it is only number of frame, it doesn't matter what FPS you used. Just that if I have the more number of frames to compare, it will take more time.
So I'm talking about number of frames only because I'm breaking down. So maybe the video into number of frames.
So
I'm saying suppose you have broken down into 200 frames. So
like, okay,
it is broken down into 500 frames, or if I have broken down to only 50 frames, the analytics may change. Correct?
Say it again.
If I am saying a job which is performed, say, what is your total video time that you have done this one cycle approximately?
So it was, I think, 15-20 seconds. Yeah.
Okay, 20 seconds. So now 20-second job, I have say broken down to 200 frame example. Correct? And then I have this analytics which is run with the accuracy of deviation and all. Suppose I run this 20-second job only into 50 frames. Then it will show different level of deviation and accuracy, right? Because it will club few points, okay? Because it will not show points.
Agree.
Or if I break down to 500 frames, the deviation will be more because few points which are not showing as deviation, because that it will identify frame to frame deviation, correct? So selection of number of frames for a particular job is also very critical to understand that, because if the job is very critical, then I have to see 1 minute job is better to break down.
So think of it like So think of it like even a human eye cannot determine
Exactly.
more than the difference between more than 16 FPS,
Exactly.
right? So if there are more than 16 frames in 1 second, my
Yes.
eye cannot determine the difference.
Exactly. 1/16 of a
Right?
second. Correct.
Yeah, right. So if I mean like 16 FPS is like good enough for anyone, yeah, we can have we always can have
Yeah. This
these
is
those
what
kind
I'm
of things, but
saying.
those are not required at all.
Yeah, because not required. Exactly. This is what I'm saying. If I want to see more accurately, that deviation will be very high, because those deviation which is not seen by the eye, right? Sometimes is not so practically to be reported, So we have to also identify that where the deviations are not very high, or what
So
is the
those
right
things,
frame.
so
maybe,
those things you think of it like those things you just need to set it like when you capture the videos, right?
yeah. Or we can
And you need to
identify
define
as
in the
a
camera.
human thing,
Cameras
like
come with the different
as a
settings.
human thing, like if a 20-second cycle, if we divide into 200 frames, good enough for a deviation to capture. We have to also, see certain thing which is because you are right. Because first, if something cannot be seen with naked eye, so there's no need to report those deviations if it is a manual job. And
Exactly.
similarly, if you look at, yeah,
So think of it like capturing of those videos is beyond the beyond this work that we are proposing here, right? So capturing
can be on, yes,
from
the
because
input.
all the mobiles and cameras, all those things, they have the settings. You can set like what is the FPS you want to set, what is the quality, what is the pixel quality you want to choose, whether it is 720p or it is 1K, 4K. You can set all those things in the camera itself.
Okay, camera itself. And how this system will connect to the tracker engine, how this will move into your cloud server. What is the
This
mechanism
thing,
for interface?
this thing,
Yes, a video interface going to the tracker, how it is going to happen?
multiple ways to do it. There are multiple ways to do it. For example, there can be, I mean, like think of it like we can develop an interface, web application, mobile application, or anything else, which will we have a solution. We have a partner solution who has a IP camera based solution to stream it to the backend. That can be used. That can be integrated here. But that is kind of their IP, and we need to
or a phone with an application,
own as well, if you want.
with an application kind of application design can also track the thing.
Yeah.
Okay. So we have to also think of some, very cost effective for those interface also, because we have to suggest few interface. Because what I want to do is to develop a complete model, before we approach them. Because I don't want to give them multiple choices and leave few part on them. We say, okay, these are the two choices you have. Either you can have phone or you can have a, IP camera. And we have
So I will say I think phone is not a good idea.
Good idea.
The reason is that in industrial automation, you need to have some fixed cameras. I mean, like
cameras, yes.
Nobody will be holding a phone to just record what the person is doing on the assembly line, right?
Yes.
So I think IP cameras should be good, and we should just have a mechanism to capture the streams from the IP cameras to our server.
To a server directly, right? That can be mapped.
Or indirectly. So so think of it like, since we are saying the first phase should be offline analysis, it means they will not see it real time, right?
Correct.
So if it is not real time, means there might be a lag. They can upload the videos here to the server, and then from there we can start doing all this remaining things, and we can provide the result. So it can be simple upload a file maybe.
Okay.
Maybe in phase right in phase 2 it can be kind of a integrated solution wherein we also provide, let's say, IP camera, which is integrated with our cloud maybe, or we suggest, okay, this is how you can connect your normal camera to our server.
Right. And if I say they put the video and connect with the, say, tracker engine with some interface, so the analytics will be shown to particular thing in a like packets coming and then showing. So what should be the rate? Suppose even if you think of offline also, say after certain videos which is uploaded, then converted into some kind of analytics, then again going. So what is the uh, the lead time that they can see, and again we have to have some interface of analytic engines with their output system, because we cannot mail every time. So what should be the output interface that they can
Yeah,
see, and what should be the lag behind between the streamed videos?
as I mentioned here, like yeah, I got the question.
Yes.
So you have two questions. One is where do they see the output, and what is the lag, right?
Yes. Yes.
So this is what I've shown here. We can have a mobile app, we can have a web application, which can fetch the results from the server and can show it in some of web UI. Number one, about the lag. So once the video is uploaded onto the server, within next 5-10 minutes, the result should be visible on the app.
Okay. So let's say probably 10 to 15.
Upper side in the sense it should be less than 10 minutes. Yeah.
So we can say 10.
Upper side means very upper side actually. There should be kind of
seconds. I know.
Yeah, few seconds, but for now, phase one, I'm not putting some number,
Yes.
but it will be. If I say it should be in 1 or 2 minute kind of thing, but upper range, I will keep it like, let's say 10 minutes.
Can we have some kind of rules also into this system? Suppose a video is coming throughout, then say I will sample the video between 9 to 10 a.m., then say 11 to 12 a.m. till we are working offline systems, right?
Yeah.
Can we have sampled videos also for a particular time frame? And capture, we have some system that video is on, okay, that's not a problem, but my tracker engine will only track for a particular samples, for particular time samples, right? So
yeah, those things, all those things are possible.
Is also possible.
So we need to have a web solution over here, which will do all those things and will pass on the. So this is think of it like this is only the core of the solution.
Oh, yes.
What we have shown here, right? Tracker engine and analytics engine. These are just the two core components of the entire solution.
Component of this, yes.
Right? This is the core.
Core thing, yes.
On the top of it, we can put as many things as we want. Whatever you want to do, we can do in software.
Okay, this is a part of the software, right?
Yeah. So this is like, you can say this is the core technology,
yes.
Right? And on top of it, we can have a rule engine, or you can say the web server, or you can say like this web UI, mobile app, or anything else, whatever you want. Alarms, for example, let's say if you are not getting something, if let's say it is reporting some poor, we can have the ranking, and it may also send some report to, let's say, some senior management, executive management automatically, or if let's say some worker is not performing well, it can send some alarms to some people if required. All those things are possible. Notifications may come on email, WhatsApp, SMS, and everything is possible.
Okay.
So you just need to define the requirements, and once you define the requirements, basis that all those things can be worked out. But this is kind of earlier we had a feasibility challenge, whether this is feasible or not, right? Exactly. So this is just
so now it is feasible, right?
It is feasible.
Kind of core technology solution we can make it, that things.
Yeah. So we have the core technology, and we can build any solution on top of it.
Okay. And now suppose we go for one particular project, okay, and I speak to one of the clients, say 1 or 2 clients on this. So we need to map the entire thing first, like what is the size, what will be the parameter which will be needed as an input to you, which can define clearly what will be, because at the end, once we calculate the cost, and also what are the inputs requirements we should know, beforehand, we should know very clearly, so that when it is processing the things, or maybe the time or the video or the quality of the video or the cycle time of the product, that how many frames we are analyzing, so that we can know exactly how much because we have to map the entire process, okay, before we say. So what are the inputs requirements that we should know to put into this system? And we are very clear that what exactly.
Yeah. So think of it like, every company might have a different requirement, right?
Exactly.
Or so what they need to, or you might have some, or like as you work with different organizations, different industries, you might know that, okay, these are 20 common requirements that, most of the industrial companies will have. Correct. So you can list out those 20 requirements, exactly. Right? These are my 20 requirements, which every customer will have their own custom requirements, right? Correct. So those 20, based on those 20 requirements, we can define something. Okay, this is what we need more, or we don't need anything else. We are good enough to to propose a solution, architecture, and everything else on top of it, effort and everything.
Yes. So I think the first thing, if I make a concrete inputs parameter, first thing we should say, take a video of their process, that what exactly their process, so that we come to know that how many frames we can break down the whole video. And then what are the analytics final outcome requirements are, so that we also come to know that what they want to show. We know the process of converting into it as a technology, but what exactly output they are requiring, because we have to convert into some features, a specialized solution. For example, they want to know which step they have missed out. They want to see in that form, or in deviation form, or time deviation separately, that how much time you have deviated. So we'll also find out the requirements, which will be quite common to say most of the client, which has to be part of the analytics, say 90% of the time, 10% can be customized. So we'll look into, one is the input video requirement, what kind of process and video we have. And second, the output requirements, as a desired output, what are the output requirements that they look for, not for a one particular client, but overall, that what exactly will be needed. Okay.
Right.
Once we know that 90% most of the client will need this output, and mostly the videos are in this form or this shape, or then the mechanism that what you're talking about, whether it's a IP camera, or we'll think about it. So then then we can make it a model, right? Complete model that you start 90%, 95% it will meet the requirement, 5% fine tuning. Okay. With different client, we can do it. But most of the time we want a standardized solution. Basically, that's the whole idea of discussion.
Yeah.
Because otherwise we have to put every time, a lot of effort.
Correct. So it has to be kind of a standard solution, which can be then customized for each and every.
Yes.
Okay, I want this, I want that. So, but 20 requirements will be common for each. For example, like this is the core technology. On top of this, we can have, let's say, some requirements. Basis that we can have a complete solution, and then it can be ready for any industry.
Any client, right? And to make the system ready, right? For example, if we get any requirement, what should be lead time of converting everything, making a system, then, making an output analytics, and, making the whole system ready. So what time frame is the right time frame if we enter with either on a POC or actual thing? So what should
for any POC? So if it is only if it is only a POC, right? Yes. Typically, I will reserve 4 months of time. If it is only a POC, right? Okay. If it is a full-fledged product, it will take definitely a longer time.
So okay, and we also need to define that if we do for one station or one operation, or if we do for multiple operations, because we have to again make it scalable, right? Because there has to be a scale. So suppose you took one process, okay?
No, it is so yeah, I can answer this question. Yes. So yeah. So you see this thing on the left hand side, left and bottom. So this is kind of the configuration file.
Right.
Okay. So for any action, for any operation, common of these 20 data points will remain common. Okay. So what I'm defining here is, if you see in this picture, we have the this configuration file. Angus tracking input, the configuration, right?
Right.
So this configuration is something like, okay, what are the different lines? What are the different angles that I need to compare? So this is something which will vary from one operation to another operation. Rest of the solution is agnostic to any operation.
Okay. So configuration file you have to, yes.
Yeah. So this is not the only input, but we will have many more inputs, like aims to compare from how many minimum match count we need to make, what is the threshold value of rate change of angle. So we have a algorithm. So we need many more such parameters, and all those parameters can be configured here one time.
One time. Okay.
And
So,
and these can be customized from solution 1 to solution 2. So that
yeah.
is something you can say we can incorporate all those things in our solution. That's not a problem.
So yeah, the bottom line, what I wanted to know is that where our effort cost will vary when we speak to our client, right? So we should know the parameter so that when we say, okay, we'll do for your line, then it should not be like that. We are doing, say we have to do something for 2 station and 3, the cost will vary. So we have to identify the real
generic solution. It will be generic solution, and it can be applied to any operation. For example, the similar solution we are doing it for you can say this kind of a yoga kind of a thing.
Yes. Okay.
The similar solution we are working for a customer who is online.
Okay. Maybe posture or accuracy of the thing.
Exactly. Exactly.
Okay. Right, understood your point. And points we can define always on the video, like what we want to analyze, so that we can also map. Okay.
Right.
So right. So what I do now, I just take the requirement, compile, say if they are different client, what exactly will be the standardized requirement for 90%, and we'll send you all the details. And based on that, we fine tune this model, and then probably we can directly approach what exactly it is, and we'll come to know more clearly once the 90% requirements are mapped. So just give us maybe 1 week time. So let me take all the requirements and I compile it and will say that what exactly people are looking for, say 90% of the time. 10% we leave it because that may be a little bit here and there, things may vary because they're different clients and all. Otherwise, it will map 90 to 95%, I can say. It will be mapped according to their need.
Correct.
Okay, so I think that's good. You say no. This is I think this is a better solution than we were looking earlier for, you know, sensor capturing the data, doing the statistical models.
Absolutely.
I think this is a better approach. What I could find.
Right.
And there were number of data points required were very high, you know, for teaching and all. So that was consuming a lot of.
So here we just need one sample video.
Exactly.
One good sample video, and the rest of things can be done by the solution.
Okay, right. And you know, there's one interesting thing. We run one workshop that we call it factory simulation. In that factory simulation, we explain people that when you run a line, what are the problems we face, and it is a 8 minutes simulation, which require 4 hours of setup to do for people to understand. But the simulation is 8 minutes run. This 8-minute simulation tells all the problems, what I was talking about, 95% of the problem a factory faces that we simulate in 8 minutes, right?
Okay.
And they learn, but to set up that 8 minute and tell people what are the concepts and all, that takes more time, 4 hours. But the practically running of that simulated factory simulation will take exactly 8 minutes. So what I'm also looking for, if we can map that 8 minutes factory time and we'll say how these operations are happening, what is varying. So what will happen, that will become a real, what you say, an application of a, because that is quite acceptable global standard for factory simulation. So we'll also share some detail of it. It is quite similar like what you are showing, a small video you made. So their operation, their steps, and how every step operation, what are the variable parameters that we need to track as analytics, what inputs are required, and how it is impacting the business basically in terms of top management, middle management, and what are the things that needs to be seen from the operation in terms of productivity, in terms of quality, in terms of everything, in terms of time. So there are multiple parameters. So maybe I will share some detail of that also to you. So along with the what you suggested for different clients. So once I compile the entire thing, and I think that will fit in here because this is my, right now feeling that will fit in into this model. Okay. How it will fit in, once you also look into it, you will also have your opinion on it, on that what exactly we are looking for. So that will give a very clear picture, I think, if we
Sure.
because that is what we use people to explain their process or to explain their issues and problems. So it's a wonderful thing that
Absolutely.
the model has been created already. So there no need to look wide variety of requirements if everything get fitted in. And some of the requirement definitely which is coming to us will also analyze it and compile it. So maybe within 6-7 days or within 10 days, we'll give you all the details now, because this is giving us some confidence that it will work. Because this is what we were actually thinking, that there is a reference model from where you can compare it. But earlier everybody was looking for a 1 lakh data point on a machine learning kind of module.
I know.
Which are not fitting into our requirement, because that is not we were expecting.
Exactly.
Yes.
Exactly.
Yes.
Exactly.
I think this is quite good what I could find it, and quite relevant. So let's see if I give you more details and what is your opinion on it. If that matches also and you find it comfortable with this kind of model, then I think this will work.
Sure. I think that will work. Yeah.
So we'll again meet within, say, maybe within a week or 2 weeks, so that we set up another meeting, and I will send you before setting up another link. We'll send you all the details on mail.
Sure.
Right. So just go through it, and then we'll have another set of meeting.
Yep.
And Naveen will also be back, I think, by that time. So
Okay.
Okay. So then we'll work out the cost also, everything. Once the whole requirements are clear, we'll work out what exactly it will cost us, what we have to go to the client. So all things will work out. So let's have first technical parameter, frozen, so that no other element can add to it. Yes.
Right. And just to tell you, Alok, now I'm kind of, you can say, running my own company here.
Okay, wonderful.
So we are working for some US-based customers. So I have quit my job and full-time focusing on.
So that's wonderful. At least now you have freedom. Earlier, there's also a constraint, to discuss. Okay, then we'll work now. That's not a problem at all. Earlier they were more constant because you are referring to some other guy.
We have a company actually.
Yes.
No. We now have a company actually.
Okay.
So we have a company who's registered in India, and we are registered in US as well now.
Okay, good.
And we have partners in US.
Okay. So okay, good. So you have more partners now with you?
Yes. More partners.
Okay.
We are working as one company. In India, I am heading the company. In US, my partners are heading the company.
Okay, wonderful. Right. So you can take all your decision here now. So that's the main thing, right? So you don't have
to I can take all my decisions.
So that's more important. You don't have to refer to anyone else. Okay, so that's also a good thing. Okay, it's wonderful. So all the best also. You started your venture. So let's look forward to it.
It's been like 4-5 months dedicated that I'm working on the company only.
Wonderful. I think so. That's good. That's a good news. Okay. So we'll meet again. Thanks, Manish. Thanks for putting all the effort. So we'll discuss again.
Yeah, thank you all. It was quite interesting, Alok.
Yeah.
I think that looks feasible right now.
Now speak to that guy, Sata Vikas guy, another guy, in.
But I'll actually go through the video also one more. I was having a little bit of disconnection.
No, I will send you the details. So
yes.
And once you're back, we'll discuss also.
Yeah. Okay. Thank you.
Okay.
Thank you.
Okay.
Okay. Thank you.
Okay.
Bye.
Bye.